Okay, so replacement and non-replacement is a pretty straightforward idea. Either you, like for instance, if you wanted to do something with replacement, like picking something from a bag, let's say you're picking marbles from a bag and there's 10 red ones and 2 green ones. And let's say that you pick the first marble, you have to pick 2 marbles, you pick the first one and you put it back. That would be considered with replacement, and that would change that would not change the results of the picking from the bag, and therefore they would be independent events. Now if you pick a marble and then you don't put it back, now you have 1 less marble in the bag, so that you have changed the probability of the second marble being pulled, and therefore those would be dependent. And so sometimes when calculating probabilities, we must consider if the object or person is being replaced in the pool. Once again, if we did a raffle in class where I put everyone's name in a paper hat on paper and threw it in a hat and pulled the name to give away a prize, and once that person won, did not put it back, that would be non-replacement. And if I did put it back, then that would be with replacement. Okay, so in this one it says, in a study determine whether preferences for self are more or less prevalent than preferences for others. Researchers first asked individuals to identify the person who is most valuable and likable to you, or your favorite other. Of the 1,519 individuals surveyed, 42 had chosen themselves. So suppose that we randomly select one of the 1,519. What is the probability that the person we chose is their favorite other? That would be the 42 who chose themselves, so 42 out of 1,519. So that's pretty straightforward. For part B, if 2 individuals are chosen randomly, what is the probability both of them chose themselves as their favorite other? Well, that would be 15. So I'll write this one out because it might not be as obvious. That would be 42 out of 1,519. So you chose the first person, they like themselves, and then you chose the second person who likes themselves. Okay. And then compute the probability that randomly selecting 2 people, their favorite author, and assume independence. So they're putting the person back in. So the first one would be a 42 out of 1,519 chance, and the second would be a 42 out of 1,519 chance. So you could technically pick the same person twice in this part C result. So you can kind of see how replacement works. This one is obviously dependent because once you chose this person, that person's no longer in the list, so this has changed the probability. This one, both picks are independent because you put the person back into the list. Here is the work for it. Okay, so you can see that in the book, or you can see it here. Either way is good. And then finally, 2 events, E and F, are both independent if P of E, given that F has occurred, is equal to P of E, or equivalently if P of F, given that E has occurred, is equal to P of F. And that goes back to the work I showed a minute ago with the cancellation of the formula. So you can see this in the help video. Consider the widowed one earlier and the P of widowed given that they're female. The events widowed and female are not independent since they are not equal. In fact, knowing that the individual is female increases the likelihood that the individual is widowed, because obviously males are less likely to be widowed in this example. So I hope you guys are understanding. Make sure you're reading the book, make sure you're doing your studying, you're showing up to online meetings, and I think everything will be fine. Thank you guys.